would explode and destroy all of New York City, parts of Connecticut and New Jersey. This is one of the greatest mysteries in all of physics.
What if one of the brightest stars in our night sky has been hiding a deadly secret all along? Betelgeuse, the fiery red supergiant blazing in Orion's shoulder, has always fascinated scientists and stargazers alike. But recent discoveries have revealed shocking truths that shatter everything we thought we knew about this cosmic giant. Far from being a predictable star nearing its end, Betelgeuse has now been exposed as part of a chaotic binary system, one that could unleash far greater destruction than anyone expected. Stick with me, because what's happening with Betelgeuse could change our understanding of how stars live and die. The shocking discovery that changed everything July 2025 will go down in astronomy history as the month in which everything we thought we knew about Betelgeuse got turned upside down. Astronomers have finally confirmed, and even captured, a tiny companion star tightly orbiting the red supergiant Betelgeuse, and this discovery has sent the scientific community into absolute chaos. For decades, Betelgeuse has been astronomy's most famous mystery. This massive red supergiant in the constellation Orion has been flickering, dimming, and acting absolutely bizarre for years. Scientists thought they had it all figured out, just a dying star getting ready to explode. But they were dead wrong. The companion star, which researchers have playfully nicknamed Beetle Buddy, has been hiding in plain sight all this time. The researchers said on the 21st of July, 2025, that the companion has an estimated mass of around 1.5 times that of our Sun. It appears to be an A or B-type pre-main sequence star, that is, a hot, young, blue-white star that has not yet initiated hydrogen burning in its core. This isn't just some small rock floating around Betelgeuse. We're talking about a legitimate star that's been dancing around this cosmic giant for who knows how long. The fact that it took us this long to spot it shows just how much we still don't understand about our own cosmic neighborhood. The discovery explains so many weird behaviors that have been puzzling astronomers for years. All those strange brightness variations, the mysterious dimming episodes, the unpredictable flares, they weren't signs of an imminent explosion like everyone thought. They were the result of this hidden companion star messing with Betelgeuse's natural rhythm. The great dimming wasn't what we thought. Remember the great dimming of 2019 to 2020? From late 2019 to the beginning of 2020, Betelgeuse dimmed so sharply that astronomers thought the star was on the brink of exploding in a supernova. The internet went absolutely crazy with predictions that we were about to witness the cosmic fireworks show of a lifetime. But here's the thing that's got scientists completely freaked out. The great dimming wasn't a sign of an imminent explosion at all. It was something much more complex and potentially more dangerous. The dimming was caused by Betelgeuse literally burping up massive clouds of gas and dust. But what triggered these burps? The companion star. It was completely crazy, Dupree says. It turned out the star had burped up material that cooled into an obscuring cloud of gas and dust. But now we know that these aren't random events. They're part of a cosmic dance between two stars that's been going on for thousands of years. The really scary part: these interactions are accelerating. The companion star is slowly spiraling closer to Betelgeuse, and each orbit is stirring up more violent activity in the red supergiant. What seemed like natural stellar behavior is actually the result of an increasingly chaotic binary system. Scientists are now looking back at decades of observations with fresh eyes, and what they're finding is absolutely terrifying. Every major dimming event, every unexpected brightness surge, every weird spectral change can be traced back to the influence of this companion star. We've basically been watching a slow-motion stellar catastrophe unfold for years without realizing it. The timeline just got seriously messed up. Here's where things get really bad for our understanding of stellar evolution. This close binary system's future involves the eventual consumption of the companion star by Betelgeuse within the next 10,000 years, potentially affecting Betelgeuse's evolutionary timeline and supernova event. Wait, what? Betelgeuse is going to eat its companion star? That's not just astronomical drama, that's a complete game changer for when and how this supergiant will explode. When a massive star like Betelgeuse suddenly gains extra mass from consuming another star, all bets are off regarding timeline predictions. Betelgeuse itself may not last much longer than that, as it burns up its supply of helium and works through heavier elements. We still expect it to explode as a supernova soon, where soon is any time in the next 100,000 years, Goldberg says. But here's the terrifying part. That timeline was calculated before we knew about the companion star. When binary stars interact this closely, everything changes. The companion star is essentially feeding Betelgeuse extra fuel, potentially speeding up its evolution toward a supernova, but it's also changing the internal structure and composition of the red supergiant in ways we don't fully understand yet. Some models suggest that consuming the companion could trigger the supernova much earlier than expected. Others indicate it could delay the explosion but make it more violent when it finally happens. The truth is, we're in completely uncharted territory now, and our best computer models are basically useless. This discovery is absolutely terrifying. The discovery of Betelgeuse isn't just rewriting textbooks, it's fundamentally challenging our ability to predict stellar behavior. And when we're talking about a star that's going to explode with the force of billions of atomic bombs, predictability matters. The implications are huge. From better models of star formation to more accurate predictions of supernova events, this discovery is a major leap forward in astrophysics. But better models is scientists speak for everything we thought we knew was wrong. Think about it this way. If we completely missed a companion star orbiting one of the most studied objects in the sky, what else are we missing? How many other well-understood stellar systems are actually complex binary interactions that we haven't detected yet? The really scary part is that this discovery suggests that massive stars like Betelgeuse might be much more unpredictable than we ever imagined. Binary interactions can trigger sudden, dramatic changes in stellar evolution. A star that seems stable for thousands of years could suddenly accelerate toward a supernova in just decades. For Betelgeuse specifically, the presence of the companion means we can't trust any of our previous predictions about when it will explode. The timeline could be much shorter than we thought, or the explosion could be much more violent due to the additional mass and energy from the binary interaction. The hidden violence of binary systems. Binary star systems aren't the peaceful cosmic waltzes that most people imagine. When you have two massive objects locked in gravitational combat, things get ugly fast, and the Betelgeuse Betelgeuse system is showing signs of being particularly violent. The discovery explains the star's periodic dimming and brightening, not as signs of an imminent supernova, but as effects caused by a small companion star dubbed Betelgeuse. But calling these effects is like calling a hurricane a light breeze. Every time Betelgeuse swings close to Betelgeuse, it's literally ripping material off the surface of the red supergiant. This stolen material forms streams of hot gas that spiral around both stars, creating massive shockwaves and radiation bursts. It's like watching a cosmic vampire slowly draining its victim. The gravitational forces involved are absolutely mind-boggling. Betelgeuse is already so massive that its surface gravity is warping space-time around it. Add in the gravitational pull from a companion star, and you get tidal forces that can literally tear matter apart at the molecular level. These interactions are also creating magnetic field chaos. Both stars have their own magnetic fields, and when they interact, they can create magnetic reconnection events that release energy equivalent to millions of nuclear bombs. These magnetic storms might be responsible for some of the most dramatic outbursts we've observed from Betelgeuse. What this means for Earth. Now, for the question everyone's really asking, does this change anything for Earth when Betelgeuse finally explodes? The answer is frustratingly complicated and potentially more dangerous than we initially thought. This event will be spectacular, visible even during the day, and almost as bright as the full moon. Despite its brightness, it poses no danger to Earth due to the inverse square law, which significantly reduces the radiation's impact over such a vast distance. That's the official line, but the discovery of the companion star adds new variables to consider. The problem is that binary supernova explosions can be very different from single-star explosions. When a star explodes after consuming a companion, it might create more focused jets of radiation, more intense gamma-ray bursts, or more exotic forms of high-energy particles. Could an exploding star, a supernova, cause a mass extinction on Earth? One study suggests that it may have happened twice already. While Betelgeuse is probably too far away to cause direct extinction, the binary nature of the system introduces uncertainty about exactly what kind of explosion we're dealing with. The really worrying part is that we don't fully understand how the companion star will affect the supernova mechanism itself. Will it create a more symmetrical explosion, or will it cause asymmetrical jets that could be more dangerous? Will the additional mass make the explosion more violent overall? Scientists are being cautious in their public statements, but privately, many are concerned that our distance calculations and safety assessments might need to be completely revised based on this new information about the binary system, the James Webb Telescope's disturbing findings. The James Webb Space Telescope has been turning its incredible infrared vision toward Betelgeuse, and what it's seeing is adding even more mystery to an already confusing situation. Beyond the misconceptions and myths surrounding Betelgeuse and its dimming phenomenon, there is a belief that this star is on the verge of exploding as a supernova at any moment. Webb's observations are revealing details about Betelgeuse's structure that are completely baffling astronomers. The star appears to have multiple shells of ejected material surrounding it, suggesting that the interactions with its companion have been going on for much longer than anyone realized. Even more disturbing, Webb is detecting complex chemical signatures in these shells that suggest Betelgeuse has been through multiple episodes of violent mass ejection. This isn't a star that's slowly aging towards supernova. It's a star that's been in crisis mode for potentially thousands of years. The temperature variations across Betelgeuse's surface are also more extreme than expected. Some regions are significantly hotter than others, creating convection patterns that are unlike anything we see in single stars. This suggests that the companion's gravitational influence is creating internal chaos within the red supergiant. Perhaps most concerning, Webb is detecting high-energy emissions from the region around Betelgeuse that seem to pulse in rhythm with the companion's orbit. This could be evidence of particle acceleration processes that we don't fully understand and that could make the eventual supernova more energetic than predicted. The neutrino warning system we never knew we needed. Here's something that will absolutely blow your mind. Now, at the end of 2024, if Betelgeuse were to go supernova, our first surefire signature would come in the form of high-energy neutrinos flooding our neutrino detectors all over the world in a burst spanning some 10 to 15 seconds. But the discovery of the companion star changes everything about this early warning system. Binary supernova explosions can create much more complex neutrino signatures than single-star explosions. Instead of one clean burst, we might see multiple waves of neutrinos as different parts of the system collapse and explode. The really scary part is that our neutrino detection networks were designed based on models of single-star supernovas. If Betelgeuse explodes as part of a binary system, the neutrino signature might be so different that our early warning systems could miss it entirely or misinterpret what they're detecting. This means we could potentially have less warning than we thought, or we might get false alarms if the binary system produces neutrino bursts during violent interaction episodes that don't lead to immediate supernova. Scientists are now scrambling to update their detection algorithms and models to account for binary supernova scenarios. It's like realizing you've been listening for a fire alarm that sounds completely different what you expected. Why? Other red supergiants might be hiding secrets. The Betelgeuse companion discovery is opening up a terrifying possibility. What if most of the red supergiants we think we understand are actually complex binary systems in disguise? This could fundamentally change our understanding of stellar evolution and supernova timing across the entire galaxy. Antares, VY Canis Majoris, Mu Cephei, all these massive stars that we've been studying for decades might have hidden companions that we haven't detected yet. The techniques used to find Betelbuddy required incredibly sophisticated instruments, and years of careful observation. How many other stellar companions are lurking out there, invisible to our current detection methods? This is particularly concerning because astronomers use red supergiants as standard candles for measuring cosmic distances and understanding galactic evolution. If these stars are actually binary systems with unpredictable behavior, then many of our fundamental assumptions about the universe might be wrong. The implications for supernova prediction are staggering. We currently monitor dozens of red supergiants that could explode within the next million years. But if many of these are actually binary systems, then our timeline predictions are essentially useless. Even more worrying, some of these potentially misunderstood binary systems are much closer to Earth than Betelgeuse. If we've been underestimating the violence and unpredictability of their eventual explosions, we might be in for some very unpleasant surprises. The technology that made this discovery possible, the detection of Betelgeuse, required some absolutely cutting-edge astronomical technology that's only become available in the last few years. This discovery literally wouldn't have been possible even a decade ago, which raises disturbing questions about what other cosmic secrets we're still missing. The astronomers used a technique called adaptive optics, combined with coronagraphy, to essentially block out Betelgeuse's overwhelming brightness and reveal the much fainter companion star. It's like trying to spot a candle next to a massive searchlight. The technical challenges are absolutely insane. The team closed with a call to the community to turn their instruments toward Betelgeuse on 26 November 2027, when the companion will once again be at its greatest angular separation. This suggests that the companion is only visible at certain points in its orbit, which explains why it took so long to detect. The fact that we needed such advanced technology to spot a star that's 1.5 times the mass of our Sun orbiting one of the most famous objects in the sky is absolutely mind-blowing. It makes you wonder what other massive objects are hiding in plain sight throughout the universe. Ground-based telescopes equipped with the latest adaptive optics systems are now being turned toward other red supergiants to search for hidden companions. The early results are already suggesting that binary red supergiant systems might be much more common than we ever suspected. The observation campaign that's rewriting history. The international astronomical community has launched the most intensive observation campaign in history to study the Betelgeuse system now that we know about its companion. Every major telescope on Earth is being pointed toward Orion, and the data they're collecting is absolutely staggering. Radio telescopes are detecting complex electromagnetic emissions from the interaction region between the two stars. X-ray observatories are seeing high-energy flares that seem to correlate with the companion's orbital period. Infrared telescopes are mapping the temperature variations across both stars with unprecedented detail. But perhaps most importantly, gravitational wave detectors are being trained on the system to look for the subtle space-time ripples that might be created by the orbital decay of the binary system. If Betelgeuse is really spiraling into Betelgeuse, we should eventually be able to detect the gravitational waves from this cosmic death spiral. The data coming in is painting a picture of a system that's far more dynamic and violent than anyone imagined. The two stars aren't just orbiting each other peacefully, they're locked in a gravitational battle that's literally tearing both of them apart. Some observations show evidence of matter streams flowing from Betelgeuse to the companion star, while others suggest that magnetic field interactions are creating massive stellar flares. It's like watching a cosmic disaster movie in slow motion. What happens when they finally merge? This close binary system's future involves the eventual consumption of the companion star by Betelgeuse within the next 10,000 years, and what happens next is the stuff of astronomical nightmares. When two stars merge, the results are always spectacular and often catastrophic. The merger process won't be quick or gentle. As Betelgeuse spirals closer to Betelgeuse, the tidal forces will literally rip the smaller star apart, Its material will form a hot, swirling disk around Betelgeuse before eventually being consumed. This process will dump enormous amounts of energy into the red supergiant's outer layers. This additional energy and mass could trigger the supernova explosion much sooner than natural stellar evolution would suggest. Instead of waiting hundreds of thousands of years for Betelgeuse to naturally exhaust its fuel, the merger could cause a catastrophic core collapse within just a few thousand years. But here's the really terrifying part. Merger-triggered supernovas are often much more violent than natural ones. The additional rotational energy from the consumed companion can create extremely powerful jets of high-energy particles that shoot out from the explosion at nearly the speed of light. If Earth happens to be in the path of one of these jets when Betelgeuse finally explodes, the consequences could be much more severe than current models predict. We're talking about radiation levels that could potentially damage our ozone layer and affect life on Earth in ways we're only beginning to understand. The revelation that Betelgeuse is part of a hidden binary system has upended our understanding of this iconic red supergiant and challenged long-held assumptions about massive stars. What was once seen as a predictable, solitary star has been redefined, with its mysterious great dimming now linked to stellar interactions rather than an imminent explosion. This discovery not only raises the possibility of a far more violent supernova if the two stars eventually merge, but also forces astronomers to reconsider whether other red supergiants might be concealing companions of their own, reshaping models of stellar evolution and supernova prediction across the universe. What do you think this discovery means for our understanding of the universe? Are we completely blind to the cosmic dangers lurking in binary systems we haven't detected yet?